Hi class, this is lesson 10.4, finding probabilities of disjoint and overlapping events. Our big question right here is a problem like find the probability of getting 0, 1, 2, 3, or 4 red cards when you draw 5 cards. This can require many computations. How can you simplify the solution? So here's your frame. Let's look at your 10.4 frame. 10.4 is about compound events, and this is about determining the probability of two events when they have common events or else separate events. So determining the probability of two events when they have common events or they have all separate events. So they have something in common or everything's separate. So you're going to have to decide that. So we're finding the probability of compound events. If A and B are any two events and the probability of A or B, here's the key word, A or B, so one thing or the other happening, is this. So we do the probability of A plus the probability of B, and then we subtract from that the probability of A and B. So we subtract how many ways you can get both A and B. So our first example, you roll a 6-sided number cube. So you've got 6 outcomes possible there. What's the probability of rolling an odd number? So 1, 3, or 5. Or, here's my key word, or, so you want one or the other, a number less than 3. So that'd be 1 and 2. Now notice they both share 1, so they have an outcome in common. So our probability of an odd number is 3 out of 6. Plus our probability of a number less than 2, there's 2 out of 6 there. But we've got to subtract what they have in common. They have 1 out of the 6 in common. So we've got to subtract that. So our total is 4, 6. They have a common denominator, so we can just combine the tops. 3 plus 2 minus 1 is 4 out of 6. And that reduces to 2/3. And the next one, a card is randomly selected from a standard deck of 52 cards. We looked at cards a little bit yesterday. What is the probability that it's a face card or a spade? So face cards, we've got 4 suits, and each suit has 3 face cards, so we've got 12 face cards. A spade, we've got 13 spades, but you have to remember, for both of them, we have 3 cards that are in both, because we've got 3 cards that are face cards and spades. So our probability is going to be 12 out of 52 plus 13 out of 52. And then we have to subtract what they have in common. They have 3 in common out of 52. So my denominator is going to stay 52. My numerator, well, we're going to do 12 plus 13 and then minus that 3. That'll give us 22 out of 52. And if you reduce it, that's 11 out of 26. So now we're going to find the probability of disjoint events. Okay, so if A and B are 2 disjoint events, so they're 2 separate events, that's what disjoint means, then the probability of A or B is the probability of A plus the probability of B. So disjoint means they're separate events. And again, we're doing the probability of A or B happening here. So our example, you roll a 6-sided number cube. So again, we've got 6 outcomes there. What's the probability of rolling a 2 or a 5? Okay, so to get a 2 or a 5, there's one way of getting a 2. So our probability for a 2 is 1 out of 6. And our probability of getting a 5, well, we've got 5 out of 6. So we're going to add those together. And our probability is 2 out of 6. So one thing is happening here, we're just rolling the die once, but we want one of the 2 outcomes there. So my answer is 1/3. My next one, you roll a single-sided number cube. What's the probability of rolling a 1 or an even number? So there's one way to roll a 1, and we've got 2, 4, and 6. Those are our even numbers. And notice they don't have anything in common. So this is disjoint because our 2 events are completely separate. So our probability of rolling a 1 is 1 out of 6. Plus our probability of rolling an even number, that's 3 out of 6. And then there's nothing in common, so we don't need to subtract anything. So our total is 4 out of 6, and that reduces to 2/3. Okay, this example says use a formula to find the probability of A and B. So in a survey of 300 students, 150 like pop music or country music. There are 97 students who like pop music, and there are 83 who like country music. What's the probability that a randomly selected student likes both pop music and country music? So we know the or part, we need to find the and. So our probability of A, and that's our probability of pop music. Well, we know that we have got 97 out of our 300. The probability of B, that's going to be our country music. We know that we have 83 out of 300 who like country music. And our probability of liking pop or country music, well, that's 150 out of 300. So to find the probability of or, what that is, it's the probability of A plus the probability of B minus the probability of A and B. And that gives me the probability of A or B. And our unknown here that we want to find is the probability of A and B. So we're really just going to make an equation. So the probability of A is 97 out of 300. Probability of B is 83 out of 300 minus the probability of A and B, that's what we're trying to find, is X out of 300. And that equals my probability of A or B, which is 150 out of 300. And since these all are a fraction, they all have the same denominator, I'm just going to cancel out my denominators and use my numerators to solve this equation. So I have 97 plus 83 minus X equals 150. So this is 180 minus X equals 150. So if you subtract 180, you get the opposite of X equals negative 30. So I'm left over with X equals 30. So my probability, or actually, yep, says what's the probability that a randomly selected student like both pop and country music? Well, that's 30 out of 300, which is, if you reduce that, that reduces to 1/10. So our probability is 1/10. Okay, let's look at the back side of your frame here for 10-4. Complement. So this is about the complement of A that consists of all the outcomes not in A, and it's denoted like this, A bar. We read that A bar. It's an A with a little bar across from it, or across the top of it. So the complement is how many things are not in a certain set. So our main idea here, we want to find the probability of the complement of an event, A, or P of A, or P of A bar, that is, and it's 1 minus the probability of A. So to find A bar, the probability of A bar, we do 1 minus the probability of A. So we're going to find the probability of complements here. When two 6-sided dice are rolled, there are 36 possible outcomes. Find the probability that the sum is not 4 and the sum is greater than or equal to 3. So first, let's find this probability that the sum is not 4. So in order to find the sum that the probability that the sum is not 4, we're going to do 1 minus the probability of the sum being 4. So that's 1 minus, it's 4, 3 of the 36 times. So that's my probability of getting a 4. And if I subtract that, that's 33 out of 36, which reduces to 11/12. And that's the probability that it's not 4. So the probability of having a sum greater than or equal to 3, well, let's find the probability of the sum being not greater than or equal to 3. So if we want the sum to be not greater than or equal to 3, well, my only options right here are 2. So the probability of it not being greater than or equal to 3 is 1 out of 36. So we're going to do 1 minus 1 out of 36, and that gives me 35 out of 36. Our extra example here from the dice example, find the probability that the sum is not 8. Okay, so in order for it to be 8, the probability of the sum being 8, well, that's 5 out of 36. And you can just count how many ways it adds up to 8. So the sum not being 8, that probability is going to be 1 minus 5 out of 36. And if you reduce that, you get 31 out of 36. So that's our probability that the sum is not equal to 8. And this was the end of this notes. This is a pretty quick lesson. Make sure you start anything if you have any questions on it so that we can talk about it tomorrow. Have a great day.